Hello and welcome to Eyes on Research, the podcast that digests the latest scientific innovations in eye research using simple and understandable terms. I am your host, Thales Guimarães, medical doctor and clinician scientist at Moorfields Eye Hospital. Welcome to the second episode of this podcast. Today we'll be talking about adaptive optics and its applications in ophthalmology. Here with me today, I have the great pleasure and honor to introduce you to one of the most experienced and knowledgeable scientists in the field, and my friend, Dr. Angelos Kalitzeos. Dr. Kalitzeos is a senior research associate at the Institute of Ophthalmology and honorary research fellow at Moorfields Eye Hospital, with a background in engineering, electronics, and optics. He completed a PhD in retinal vessel analysis and has several years of experience with advanced retinal imaging, including adaptive optics imaging of single photoreceptors in humans in vivo. He participates actively in patient and public engagement activities and supervises research projects on a regular basis. He's also an associate fellow of the Higher Education Academy. So, Angelos, thank you very much for being here with me today.
Talis, it's a great pleasure. Thank you for inviting me.
So, I think, Angelos, we can really start from the beginning here. What exactly is adaptive optics?
Thank you, Talis. Adaptive optics, as the name suggests, is a technique that uses optical elements that can adapt to imperfections of an optical system as a general kind of description. So the key word here is adaptive, and we're using special elements to adapt to real-time changes.
Right, that's very nice. And what is the application of adaptive optics in general?
So adaptive optics really started in the field of astronomy in order to visualize distant stars. And as most people listening now will be familiar with, before we had adaptive optics, we had to send telescopes into the orbit around the Earth, like the Hubble telescope, which is a very famous, one of the earliest telescopes. And this was very expensive. So nowadays, actually, it's cheaper to keep the telescope on the surface of the Earth and use what we call, as we say now, adaptive optics in order to see distant stars, not only in spending less money to actually put the telescope in orbit, but actually in much better resolution and image quality.
As a space nerd myself, as you know, that really hits home, and I could discuss this with you for many hours. It's such a fascinating field, but
Exactly.
it's very interesting what we can do in astronomy. But how does AO fit within ophthalmology then? Because now we're going from far away things to things that are close to us but are small. So how do we go in ophthalmology with
Exactly.
that?
So the analogy here between astronomy and ophthalmology is the fact that there are turbulences and between the Earth and the distant stars, and the optical system in that case is our object that we want to image is the star, and the light needs to travel through a various number of layers in order to reach the star, and then it becomes distorted, and that's why we need adaptive optics. So the analogy in the human eye and ophthalmology is very similar because we're using the eye as a target and the retina as a target, the back of the eye as a target, and we need to see an image of that object. So we also have imperfections because the light needs to go through the front of the eye, which is essentially what there are two main layers, which is the cornea and the human lens, and then it needs to travel through the jelly of the eye and reach the retina. So even a perfect eye actually is not perfect. A perfect eye doesn't exist. Let alone in an affected eye. So these images will become very blurry. So that's how adaptive optics comes in.
That's very interesting, and it's a very nice convergence of fields, isn't it?
Exactly.
So just to clarify, we can zoom in with a lot of accuracy then, and we can actually see individual cells in the retina. Is that how adaptive optics work? And also, can we see anything else other than these cells?
Exactly. That's a very good question. So Without adaptive optics, all we would see it would be like a blur and a noise of a dark picture. Because one of the reasons is, of course, that the retina is a very bad reflector, so light doesn't bounce off much back out the eye. Um, so by actually using adaptive optics, and for example, my eyes are, let's say, short-sighted, so I use glasses, and my prescription is actually quite high, in the order of, let's say, 6 diopters. So what adaptive optics would do is it would cancel my prescription out, for example, and make it -6, make it a +6, so then it becomes a 0, so it cancels it out, and in effect, my eye becomes sort of a perfect eye. And these blurry cells would actually now become in focus, will come in focus. So we're talking about cells that are down to 2 microns, the smallest of the cells, so very, very small. And in order to distinguish this, your resolution, the capability of your system to resolve the cells, needs to be at least at that level. And
Hmm.
indeed, we can resolve the photoreceptors of the human eye, which is essentially the ones that collect light and sends the signal back to the brain. And it could be both, either cone photoreceptors or rod photoreceptors. So these are responsible for daytime vision and nighttime vision, respectively.
Right, it makes a lot of sense. So we can actually see these cells. Is there anything else that we can also see with AO, or something that AO may help us in the future to analyze?
Yes. So not only we can see them, we can also quantify them. So we can, apart from taking nice pictures, we can also put numbers to the pictures, and potentially we could see other cells that currently are not able to be visualized. And the reason for that is because some other cells that are maybe at the further steps of vision, such as just before they reach the brain. The reason for that this being actually difficult, that doesn't happen yet, or it's very difficult actually, is that these cells are by nature, they're transparent. So unfortunately, the contrast between light and these cells is very low, and one needs to either acquire a lot of images so they can actually resolve the cells. So we're hoping in the future, the research community is hoping that they can come up with nice and smart ideas to be able to extract information even from almost transparent cells. So yeah, these are called ganglion cells, for example.
Hmm. Right. It's truly amazing, that science and technology have evolved that much to allow us to be here today. Because, and this is for our audience, the power of a technology like adaptive optics enables us to see not only photoreceptors, but a lot of other different tissues in the retina. And that, as Dr. Angelos was saying, further steps down the visual pathway to the brain. And also perhaps it can help us see blood flow, that sort of thing. So I can think of many applications of AO, and it really has the potential to shape ocular research, retinal research in particular. So, for example, we can understand disease progression in diseases that affect the photoreceptors, but we can actually measure changes in blood flow in patients who are diabetics, for example, which may help in monitoring them and can explain long asked questions, such as why is it that patients may have diabetic retinopathy and may be progressing even though they have apparently controlled glucose levels. And I think one of the most important applications, and I know that it's one that you're heavily focused, Angelos, is measuring response to new treatment in drugs that are being tested in clinical trials. This is really fascinating. um, with that being said, I do have a final question to you, which perhaps is the most difficult one, Angelos. What do you actually think the future of AO in ophthalmology is, and also should we expect this technology to be readily available everywhere?
Thank you, Thales. That's a really good question. And I think we've gone a long way since adaptive optics came into ophthalmology, which is approximately the late 90s. And I would say that the future is actually already happening. Um, what I mean by that is that there are commercially available devices that already use adaptive optics. Of course, the trade-off is that they may not have an ideal resolving power like maybe more research devices have. But I would say that adaptive optics is here to stay. It's a complementary technique to current clinical well-established techniques such as optical coherence tomography, and it can be combined with various modalities like optical coherence tomography. And I believe it has a place in the clinics and in everyday in everyday research, because your next question is, I think prices will go down in terms of whether they will become more affordable. So technology becomes more widely available, and the speed can also get increased. And I believe that this will be an option for many more either hospitals or research institutions to incorporate into their day-to-day work.
I agree, Angelos, and hopefully we can get to this point soon where we can actually use AO in a very clinical setting. Angelos, thank you very much for your participation in this episode.
Thank you, Charles. It was a real pleasure.
And to our audience, I'll see you in the next episode.